Hey guys, Fadil here, and today I'm gonna teach you how a capacitor works. But Fadil, what is a capacitor? Well, you see, the capacitor is basically, in its simplest form, two conductors separated by an insulator. So, what are the uses of a capacitor? From what I know, they're used mostly in like pulse circuits and to filter AC from DC and vice versa. I'll talk about those in a later video if I even remember. But Fadil, how does a capacitor work? Well, when a voltage is applied to a capacitor, both the plates charge up. One plate will have negative charges and the other plate will have positive charges. And when the voltage supply is removed, the electric field between both the charges hold them in place until a load is applied. And when a load is connected to a capacitor, the negative charges of one plate go through the load back to the positive side, and then both the plates become neutral. Oh, Fadil, you're so smart. Yeah, thanks, man. Okay, so we've finished learning how a capacitor works, and now we're gonna learn how to calculate the capacitance of your capacitor. Equation number 1, C equals to Q by V. When we divide the charge between two conductors divided by the voltage between the two conductors measured in coulombs and volts respectively, we get a constant known as the capacitance between both the conductors, which is measured in farads. Usually a farad is quite a large value, so we use values like picofarads or microfarads. Now remember this, okay? 1 microfarad is equal to 10 raised to minus 6 farad, and 1 nanofarad is equal to 10 raised to minus 9 farads, and 1 picofarad is equal to 10 raised to minus 12 farads. So remember this formula, and the rest of the stuff might just be very easy for you. Equation number 2, the capacitance of the parallel plate capacitor. So a parallel plate capacitor is basically two conducting plates separated by a small distance. So the electric field of one plate is given by the equation rho by 2 epsilon 0, where rho is the charge density and epsilon 0 is 8.85 into 10 raised to minus 12 coulomb square per Newton meter square. Now we add the electric fields between both the plates and we get rho by epsilon 0, and then we substitute rho for Q by A, and then we get Q by epsilon 0 into A. Now we know that the voltage is equal to electric field times distance. So we substitute our first equation in this equation. So now we get Q into D by epsilon 0 A. We also know that capacitance is equal to charge by voltage, and we substitute our new equation into this equation, and now we get epsilon 0 A by D, where A is the area of the plates and D is the distance between the plates. And there you have it, that's your equation. And now the last equation, the capacitance for a capacitor with a dielectric in between them. This is the most common type of capacitor used nowadays, and guess what? You can actually make one yourself, which I'm gonna do after I explain this. Now we know that the capacitance for a parallel plate capacitor is epsilon 0 A by D, and now we're gonna add a K to the equation. The value of K here is known as the dielectric constant of the medium. For air, the dielectric constant is 1. And for water, it's about 78. So how does the dielectric constant affect your capacitor, you ask? Well, for one, the capacitance of your capacitor would increase, okay? But that also means that your capacitor can't take high voltages now. So why does this happen? Well, you see, capacitance is inversely proportional to the voltage. So if you want a capacitor with a very high capacitance, you might have to sacrifice some of your voltage. Anyways, that's it for the end of the video. If you guys have any suggestions or any corrections that you think I should... Fadil? Yeah, what? You said that you'll make a capacitor. Where is it? Oh, yeah, the capacitor. Yeah, hold on. Okay, I'm back. So to make your own capacitor, you'll need three items. Okay, some paper, some aluminum foil, and some wires for connecting. So firstly, you're gonna glue two aluminum sheets on both sides of a piece of paper. And then you tape some connecting wires to the aluminum foils with some normal ass tape because I can't afford electric tape. And after that, you cover both the sides with some more paper, and voila, you've got your own capacitor. So the dimensions of the aluminum foil is 10 into 4 centimeters, and the dielectric constant of paper is 3.7. So using the equation, I figured out that my capacitance was 2619 picofarads. So yeah, not a big number. So what we can do to increase the capacitance is to roll the capacitor. This way the capacitance would increase a little. I've heard somewhere that the capacitance would double if I roll the capacitor, but I can't check it because my multimeter can only measure voltage, current and resistance. So if any of you knows about this, please comment down below. I'd like to hear your opinion about it. And yeah, that's it for the video today. Hope you guys learned something from it, and I'll see you guys in the next video. Peace.